My name is Bill Ticehurst. I work at Microsoft on various JavaScript developer tools, one of which is TypeScript. And I'm here today to talk about what's new in TypeScript. Specifically, I'm going to try and cover from 1.5 onwards, so that's the last 3 months of releases. And I'm going to go through some of the value props of TypeScript in general, just to encourage you why you should use it as I talk about some of those new features. I got 25 minutes and a ton of content, so I'm going to rip through it. If there's anything you're not clear on, there's an Ask Me Anything tomorrow. Please come there and I'll be happy to answer any questions. So one of the goals we started with TypeScript is just to make JavaScript development more productive and more enjoyable. When we looked around at what was happening in the community then, there was things like Google's Closure compiler. Even internally at Microsoft, some teams were doing things like ScriptSharp in the Office team to try and really solve the problem of working with these really large JavaScript code bases that people were starting to develop. And the challenge there is your JavaScript code gets really hard to reason about. You know, when you're talking about a few 100,000 lines of code, trying to understand the structure there and how things interrelate is really difficult. A lot of people were telling us the code almost becomes read-only, right? People are extremely scared to go in there and start refactoring things, changing things. I mean, if you can imagine having a couple of 100,000 lines of code and your manager says, hey, this heavily used component, we want to change the name property to username. I mean, what do? Go in and find replace, see what tests break. It was really hard to work in those code bases. So we came up with TypeScript. It's a type superset of JavaScript that then compiles back to plain JavaScript. We wanted something to be as usable as, say, like Java or C# at large scale. We also wanted something that was JavaScript at heart. We didn't want to take another language and then try and map those syntax and semantics onto JavaScript. The goal then being you have an output that maps really cleanly to what you wrote. You know, myself, I often turn off source maps. I'm really happy. The JavaScript that gets generated, I can map really cleanly back to the TypeScript that I wrote. Makes it very easy to debug. There's not a lot of concepts you're dealing with there of a different language. And if you decide to stop using TypeScript, just keep the JavaScript that was generated and carry on from there. So when we think about TypeScript, we really have two key value propositions. The first one being features from the future of the language today. There's a lot of great stuff happening in ECMAScript 2015, or ES6 as a lot of us call it. The expressive syntax, things like arrow functions, destructuring, template strings. Once you get used to that stuff, it's really a joy to use, and we want to be able to bring that forward so you can use that today, but still run in engines that may not have those features yet. There's better encapsulation, things like modules, classes, symbols, all that stuff really helps you keep your code clean and understandable. So we have those features, and we down-level them or transpile them or polyfill them where we can so that they can run in today's engines. Once you get used to writing in this ES6 style, like you go back and look at ES5 code, ES3 code, like you're trying to write like that or even read that code, it feels weird, right? I mean, you've got those ifs to encapsulate, you've values, you've got .prototype assignments, and var that equals this, and it's, yeah, once you get used to ES6, it's really hard to go back. The next features we added were, the other value prop we bring is static types. So laying a type system over the top of that, it really allows you to reason about that code a lot more. You can understand the shapes of objects and interfaces, get documentation and assistance calling APIs. You can jump around your code, go to where something is declared, or the various use sites. And that tooling is really enabled by having a type system over the top of JavaScript. And I'll be demoing a lot of those features today. It also allows you to catch a bunch of really simple bugs. Brad spoke about that earlier in his keynote, about some of the bugs they found in Angular just by switching to TypeScript. I'll demo some of that too, but simple typos, wrong calling functions incorrectly, invalid expressions, things that are actually valid JavaScript and do run but fail, you can catch while you're authoring your code. And the type system, we wanted to keep it as lightweight as we can. So we tried to make that kind of pay for play, if you will. You don't have to go and add types everywhere. I saw someone on a blog compare it to code coverage, right? It's like, you don't need to get to 100% to get really good quality. If you're hovering around 10%, you've probably got some bugs in there. You know, the more you add, the more value you're going to get out of it. So effectively, we have JavaScript, the good parts, from now and the future versions of the language. We layer a type system over that so that we can reason about the code. And that allows you to add some really great tooling to help you work with your code base. And at the end, we just spit out plain old JavaScript. All right, so let's get into some demos. I've got a ton to rip through here. So I'm going to be using Sublime Text. So a lot of the team, we love VS Code. Looks like Angular does too. A lot of the demos I'm seeing are using VS Code. Within our own team that develops TypeScript, I work on Visual Studio as well. We have people using that. There's people using VS Code. And you look around the room, a lot of people are using Sublime Text. It's a very, very popular editor. So my team went and wrote a plugin for Sublime Text to work with TypeScript, and that's what I'm going to work through today. So one of the first things I'm going to do is just open up this plain JavaScript file. Hopefully you can read that. It's very contrived. I just wanted to highlight some bug finding properties. I've tried not to use any external libraries, so there's no Angular here yet. But there is at least half a dozen bugs in here, all of which I'm guilty of writing myself. So take a couple of seconds while I take a quick drink and see what you can spot. Okay, let's go and rename this to TypeScript. So all I've done is rename this file to TypeScript, and man, those red squiggles really aren't showing up well on here, are they? All right, well, fortunately, a new feature we added is an error list. So I can just choose to show the error list. That's going to spin up another worker process, and at this resolution, there we go. And this is the kind of thing you'll see in Visual Studio as well, right? You'll actually get a list of errors that exist in your project. So just by renaming this file, straight away it's telling me, line 1, I've got a bug. Okay, this isn't right. Can you actually see the red squiggle there on that? There is a red squiggle there, trust me. So why doesn't it like that? Well, if I go to define property, again, using types, I can just jump straight to the definition there. I can see that expects a property descriptor. Okay, what's that? F12 again. If I use the palette just to show you, let's go to definition. And I can see I have this interface which expects configurable, enumerable, value, and writable. And I'm giving it a read-only property. Okay, so that's the bug. This is actually something we added in the last release. It used to be that code would be perfectly valid, because if you look at this type, there is nothing but optional properties on it. So technically, I don't need to give it any properties. And seeing as TypeScript is structural, and you can add any properties that aren't specified, and it's a valid subtype, you can add any new properties. So if I don't require any properties, and I can add any new properties, how would you catch a typo on this? There's no way, right? It's just a new property on an object that doesn't require anything. So what we've done is we've tightened up what we call stricter object literals. If you've gone and defined a type, then when you provide an object literal, which is supposed to be that type, we only expect properties that you said might be on that type. Technically, that's a breaking change, and we run any compiler change over millions of lines of real code we have internally, and it did. It broke hundreds. There was hundreds of new errors introduced. We looked at them, and they were nearly all bugs in code due to that problem. So we've gone and added that feature, and people seem to be very happy with it. I can just Control minus to jump back here. Just using navigate back. Okay, so that should be writable false. That error's gone. The next one, okay. What type is this? When I get tooltips, I can go and look at what a type of a property is. That's a node list, because query selector all returns a list. Okay, I need to index into there. That one's gone. Some of these I'm just going to whip through because I've got a lot to show. This is another interesting one. ParseInt, and I'm giving it the HTML element. I need to get text content off of there. Now, most of these bugs, it's interesting. Do you know what happens if you pass an HTML element to parseInt? It's not an... Pass it, right? It has to go. Yeah, it's not a number. It gives you not a number, and then it compares not a number to 100, and it's false. So things still work. It's just not what you expect. So that one's fixed. what else have we got? This line here. I'm using a bitwise OR instead of a logical OR. Valid JavaScript, you bitwise OR 2 strings, and what do you get? 0, of course. So let's fix that. Okay, that's now working, or at least it should be. And ship weight larger than 100. Okay, it turns out that's a function. I'm supposed to call it. It's not a property, so I just need to add the calls on there. Again, valid JavaScript, you compare a function to a number. Do you know what that is? It's false. It's not greater than 100. So there would have never been an oversized package here. So there you have it, just simply renaming a file to TypeScript, and I caught at least half a dozen bugs. There's actually a couple more right here, and I'm going to show you the benefit of actually adding some types. Now, the way TypeScript works is we infer types where we can, but we don't use any kind of call site analysis. So parameters, we have no idea what they are. If you look at them, they're always any if you don't add a type. So I've got this JS doc type annotation here, which says it could be a string or a string array. So I'm going to put that on there. Okay, now it's saying these properties don't exist. And it's true because with a string or a string array, we only give you what we know is going to be actually there if it's either type. Turns out length is on string and string array, so that was a bad check. It would also be falsy for either if it was an empty array or an empty string, so a really poor check. We've always had we recently added type guards on type primitives, so if I say type of something equals string, within that if expression, it will check that it is that primitive type. But we added another type guard, which is like a type predicate, and I'll show that here. I can say array is array, email address. And now it knows that within here, email address is a string array, because I've checked it's the array. And here it's the string, because that's all that's left after you take string array away from that type. I'm going to jump to dev here and show you the new syntax for this. So effectively with a type guard, which is like a predicate, you can see I've got this isArray function which takes any argument. And this new syntax is what is interesting here. I'm saying if this function returns true, then the argument I gave it is an array. And that way you can write your own type guards, right? You can do duck typing for promises, like does this thing have a property which is then, which is a function, if yes, return true, right? And so you could have is promise, things like that as type guards. That's highlighted another error, trim is not valid, but hang on. If I bring up tooltip, I've got value and index back to front. So there we go. Another couple of bugs found, bugs I've written many times myself. You would have seen there the tooltips we added. That's a Sublime Text 3 thing where they've added the ability to do that, and it's really quite nice. Like it pops up. The signature help, you can scroll through them there and see what signatures are available. So, yep. Okay, next demo. Let's just delete this file. Get rid of it. So let's get in some Angular code. This should look familiar. One of the interesting things you'll notice here is I'm just importing star as ng from Angular 2, Angular 2. Now being TypeScript, if we want this to have types, it needs to be able to resolve that module, right? Well, you'll notice here I don't have any / references, which you may have seen. My typings folder, I haven't downloaded the Angular typing. And in my config file, I'm not feeding in that Angular typing file. So how is it locating that? Well, one of the things we wanted to make easy going forward is make it really easy to actually get the correct typings for libraries you're using. So we walk the tree as Node does now. If we see something like this, we'll go, okay, do we have a Node modules folder? No, to the parent, to the parent. Oh, there we go. Angular 2, whack Angular 2. Well, there's Angular 2, and it has the angular2.d.ts file. So this is awesome, right? It means I just npm install Angular 2, open a file, start using ES6 module syntax, and I'm just going to get types. It's just going to work. We really hope this catches on and people adopt this. Not only does it make authoring much easier as a developer, but even distributing the typings. You know, you use the tools today and it just always gets the latest versions of the DTS file. that may not necessarily be the version of the library your app is using. So if you distribute the typings with the package, you know you're always getting the version of the typing that matches your package. So if you're out there writing libraries, please start distributing the DTS files with your NPM packages, and they'll be much easier to use. So what else have we got here? Decorators. ES7 feature that we enable in TypeScript today. Everyone here familiar with decorators? Know how they work? 2, 3 hands? Okay. I really wanted to get into the guts of this, but I don't have time, so catch me afterwards or come see me tomorrow. Decorators effectively are able to act on an object at the time it's created. So if you see this item list here, this decorator gets a chance to interfere with the declaration of that object. You may have seen blogs where people will use a logger decorator and they'll put that on a method. That effectively injects another function that's going to wrap that method so it'll log it and then invoke the original function. Other things will typically annotate a function, so they'll go and put extra properties on the object they're decorating. If you see some of the demo code for Angular when you write it, ES5 style, you'll have that function, the constructor, and then function name dot annotations, blah, blah, blah. That's another common thing. TypeScript today, when you use Angular code, it actually uses another ES7 feature. It adds some metadata using the reflection API. So for example, if I open this here and actually look at where this is being, I'm going to refresh this and break where I have item list. So item list is my class. That's the component I decorated. And yet, if I look at item list, there's really nothing that's been added to it. There's nothing on the prototype other than my methods. The actual dunder proto is just a standard function prototype. So where is this component adding information? Where is that decorator adding information to my component? Well, if you look at reflect.getMetadata keys on item list, you can see this metadata has been added using the reflection API, which just associates values with objects. It doesn't actually modify the object itself. It's just a place, like a table, if you will. It's actually a weak map internally, that's going to go and associate some values with an object. So let's actually look at the annotations here. Annotations. And here you can see that's where that component metadata is being stored. So again, don't want to get too much into the guts of decorators and metadata. This is really handy to know if you're trying to debug this stuff and you're like, hey, well, where the hell's all that information I specified in my decorator? That's where it is. Okay. Another thing we added, support for JSX. So React was getting some popularity. We got a lot of requests to add support for this. So we did. The reason I'm showing this is because I think it shows you how when you have a templating language, which is effectively typed, which can be reasoned about, one of those value props TypeScript adds, it allows you to get a lot of help in your tooling for working with that typing language. So people here familiar with JSX, React? Okay, not too many. Effectively, you can embed HTML in your code, let's put it that way. So you can see here I'm actually writing elements directly in the code, which allows you to do some pretty nice things. Like I can say var my image equals, and then I get IntelliSense for the tags that are available. I can say source equals, and if I give it a wrong type, you can't see the errors there, can you? It's going to tell me, well, there's a lot in here. It's going to tell me, let's just get rid of that. Anyway, it's telling me here that, if you can read the bottom, type number is not assignable to type string. Great. Let's just make this valid syntax. I get incompletions. It knows what attributes are available in that element, and it also flows them through. So if I say, well, this is going to be a lambda, it knows that X has these properties because X is of type mouse event. So you get a lot of help just writing your templates, right? When you have this kind of support available in your templating language. It allows me to also do things Like within an expression, I can say, well, let's put a bunch of divs in for this, x dot, yeah, let's put a div in here, div. And it knows that's a number I'm passing through the array into a HTML element. So that's pretty cool. Also, when your templating language is well structured and you can reason about it, I can do things like, you can see here I've declared this interface on my component. Then I can go down here and just refactor rename that. Say size is now width. And it's gone and changed that up in my interface where I used that, declared that attribute. The state as well, within expressions, well, let's change ship price to ship cost. And you can see it's gone through and refactored it here, here, and, well, actually, where is that being referenced? Let me use the find references, 16, 19, 29. So again, being able to reason about code that exists in your HTML templates is really powerful. It brings those same kind of editor features you get when writing code to writing templates. That's why I'm really excited talking to the Angular team. The work they're doing to make their templating language less ambiguous, really make it amenable to tooling. So looking at this, you can think about the features that potentially could come along to help you with Angular 2, with a templating language that is really more targeted at being toolable. Another thing I like to show here is the refactor rename. I'm exporting a function, show shipping. Let's just change that to display shipping. And you can see it's jumped over to my Angular app, and it's also refactored where I'm importing it and where I'm calling it. So being able to do that across files, like you have a module that exports some names, some types, just being able to refactor at the declaration, and that stuff just propagates throughout your project and renames in the correct locations. It's not going to rename where it just happens to have a similar name or anything like that. So that's really cool. 3.5 minutes, man, okay. Let's jump into some Node code here. Now, this one's interesting because I'm targeting ES6. I'm actually going to emit ES6 code for this one, but I'm also targeting the CommonJS module type. Now, the reason we used to always emit ES6 module syntax if you were targeting ES6 emit, that makes sense. Well, it does make sense, except that lots of engines are adopting ES6 other than the ability to handle ES6 modules, because the engine support for that at the moment is a little weak. So tools like Node, which are on the latest V8 and have a lot of ES6 features in there, still require you to use the Node module syntax. So we support that now. You can target ES6 and a different module emit. So if I look in here, I'm going to whip through this because I'm nearly out of time. You can see I'm using generators. I've got a function star. I can get IntelliSense off that. If I say var iterator equals get files, and that's going to have a next method, which I can then get the value off, and it knows it's a string. Typically, you would do that using a for of loop, like we've done here, and data we can see is coming back correctly. The interesting thing we've added here when you emit to ES6 is we now support async await. So if what I'm calling returns a promise, and you can see I've wrapped a read file in a promise here, then I can just await that promise. So I don't have to do all that .then chaining. I can just say await the result of this, and then continue writing my code in a synchronous kind of style. It reads as it will be executed, right? It's quite nice. Instead of .then success error, if there's success, it just falls through to the next line. If there's an error, it throws an exception. And you can see it falls through to this line here. So one thing I didn't show you guys, Control B. We also integrate a build system now into Sublime. So you can just press Control B, and it's going to go and build your TypeScript project in there as well. That's going to pick up whatever the nearest TS config is. You can see here it's built my Node code. If I open one of these files in this folder with this TS config, and it's going to go build my client. So that's quite nice. So if I go run this, so you can see that's executed in order. Well, you could if you had the code up here. The order I've declared these files from the generator, I'm returning them, is the order that's run in, because I'm awaiting every every call to read the file. That's not very efficient. So we have this run parallel here, which is just going to go and kick off each of these using standard promises and not await them, just execute them all and then call done. There's another simple bug here. Anybody spot it? Well, I'll just run it. So now you can see this is all run concurrently because it's finished in roughly the file size order, right? The file that doesn't exist, obviously, was the quickest to read. That finished first. 5 words, 6 words, etc. Except done printed first. Okay, that's not very useful. Why not? Well, I want to await all of those promises to finish, right? And then there is a method for that. Again, using IntelliSense, if I look at promise all, you can see it creates a promise that is resolved when the array of promises completes. So I want to wait on that list. And then again, I can just say await for that promise to complete. Save and build that. Great. Is that not scrolled? Yeah, there you go. So now it's finished in the same order, but it's awaited for the completion of all of those promises before continuing on because of the async await keywords we're able to use in TypeScript. Okay, well, time's up. I think I have 2 minutes, right? Extra 2 minutes? We started late. So I'll whip through this. Features from the future today. You can look at these slides in the video. I'm sure you're familiar with most of these. All of these features come forward today, and you can use them in TypeScript. I should just note, async await and generators, this has been a big source of feedback that we don't actually down-level those. You need to target ES6 and emit. It kind of ties back to that earlier thing about trying to emit really clean code that you can read and map cleanly. When you use generators, you end up with this kind of state machine you have to transform your code into, which we've been hesitant to do, but the feedback's been so strong, we are actually working right now to get generators and async await to emit down level. So you should be in an upcoming release, you should be able to use async await and generators and emit code that runs down level. But all of these features here you can use in TypeScript today. Here's the type system we covered, structural typing. We talked about the new type guards, the new stricter object literal IntelliSense, which really helps tighten up your code, helps you type more dynamic pieces of code, which used to be quite hard in TypeScript. And then tooling. I mean, the ecosystem's been fantastic. We've got all this editor support here. A few of these my team worked on, and a bunch of it's just from the community or our partners, right? All these editor features we have in our language service, which ships with TypeScript. And you saw me demonstrate a bunch of these in Sublime as well. Obviously, VS Code, WebStorm, Atom support a lot of these features. And then we have the goodies over here. The definitely typed repo has been fantastic for us. That was entirely community-driven. TSD to go grab types. The Grunt Gulp plugins, another thing that people have created for us. It's just been incredible. So it's open source, has been since our very first release, 0.8. That was 3 years ago, 3 years ago this month. So happy birthday, TypeScript. Runs in any JavaScript host, right? It's just JavaScript. That was a deliberate goal. We wanted it to be able to run in the browser, to run in Node. Obviously, things like Visual Studio and the Electron shell host a JavaScript engine and use the TypeScript language service as well. And being that, it's obviously cross-OS. Stack Overflow, ton of stuff up there. You have questions, just go and ask them there. Lots of framework support, lots of great tooling. We're really heavily driven by the community, right? Everything's up on GitHub. Our code, we check in a master, so you see it when we see it. All our issues, all of our bugs, design discussions happen on GitHub. Please get involved. Lots of these features we prioritize based on the feedback we get. So use the product, things that bug you, things you want to see. Go and add issues, go and talk about these issues, and they'll definitely get moved up based on the feedback we receive. And that's it for me. Thanks for listening.
Thanks, man.